2, 1.
Okay, so what we're going to do today is going to be integrating composite functions. So integrating composite functions, that's anti-differentiating of composite functions. So that means we're going to have to look at the derivative of a composite function first, okay? And hopefully this will build on itself and then you'll see a pattern. So let's just develop skills from semester 1 first. So if I ask you to give me the derivative of a composite function, so let's do it in, now let's just pretend you had to read your book and you had to look at language in your book. Your book would say f of g of x. And the answer to f derivative of f of g of x is f prime, derivative of the outside, leaving the inside alone, multiplied by the derivative of the inside. That's what you'd have. So let's put some numbers to that so you can see something's going on here. So let's just say I've got 1/3. Let's do 1/3 x squared plus 5 is my f, right? So I'm going to take the derivative of this. So I'm going to take the derivative of that. Okay, it's never too early. It's not structuring the lesson yet, but identify all the parts for me, right? So you've got your 1/3 is just your coefficient. That'll just be treated as a coefficient. You've got your outside function. So we've all used the terms enough. We've used f of x for our outside function. Our outside function is, I don't want to say x squared because that confuses people because it's only an x. What I would like to use is it is x squared, but the language I would like to use is input squared. Right? It helps you think about it a little bit better. The outside function is some input. Whoops, right there. Did I do? I want it cubed. Sorry, not squared. So my outside function is cubed. I just changed it. Sorry about that. I changed this down here to a cubic. So my outside function is some input cubed, and my inside function, so we've been calling that g of x for now, is the x squared plus 5. So that would go in there. That would tuck inside there. Boom, there it goes. And then, if we're interested, we should be, because we should start noticing this pattern. I want to know what g prime of x is. But what is the derivative of the inside? Oh, that's 2x. Okay, so you haven't put all the pieces together yet. It's just random, but I'm just everyone just a bobblehead for me, right? Everything's making sense so far, right? F of x, yeah, up and down, yep. That is how bobbleheads go. But so I didn't see a lot of people moving, right? F outside cubed. I want to see the heads moving. That means you're listening. Shaking the pen in the front. Move your head. I don't want to say your name. Yes, that's subtle move head. Okay, good. Inside function derivative inside. Go ahead. It's technically we're going to do this. We're going to factor out the 1/3, and then yes, okay. So the coefficient is not part of the function. So it's going to be the constant multiple. So so we're good there. So let's take the 1/3. So let's take the derivative of that. So we're going to take the 1/3 of the derivative of x squared plus 5 to the power of 3. So we're going to change color, and here along, I'm going to follow along. So I want you to ask yourself and ask me questions if you don't understand this. So this is all semester 1. So I'm going to bring the 3 down. I'm going to multiply out the 1/3. So I got 3 times 1/3 multiplied. I'm going to do the derivative of the outside, leaving the inside alone. So I'm I'm reducing the power 1 by 1 because I'm derivative. I'm going down. Derivative going down. So x squared plus 5. Now, so let's say the statement one more time again. Derivative of the outside, leave the inside alone, followed by derivative of the inside. So now I have to follow that with a product multiplied by the derivative of the inside. The derivative of the inside is 2x. Let's clean that up. 3 times 1/3 is 1. So it's x squared plus 5 to the power of 2 times 2x. So derivative. So just refreshing you there, but is there any question on that? Just old stuff, just to make sure. It's been a long time since we've done it. All right, well, that begs the question, why are we talking about this right now? So x squared plus 5 squared times 2 of x, right? So now I'm going to push that off the screen. And this is how our problem's going to look in this section. What is the integral of x squared plus 5 squared times 2x? So now it doesn't look like you haven't had all of the build-up. There hasn't been us sitting around and saying, oh, what's the derivative of some function? And it ends up being this, right? So intuitively, you've seen all of the parts. So if the derivative of the function we're looking for is x squared plus 5 squared times 2x, what must the answer to this problem be? That has to be, right? So it's like saying, I'm saying right now, all right, I'm saying 2 times a number is 6, right? So if I divide both sides by 3, now what is 6 divided by that number? I'm just doing the inverse operation. Well, it must be that, that's all we're doing. So if I know, if I'm anti-differentiating, if I'm finding, so up on the board, whose derivative is? What you're saying is someone's derivative. I took the derivative of some function and it resulted in x squared plus 5 squared times 2x. Well, whose derivative is that? We know the answer is 1/3 x squared plus 5 quantity cubed plus c. I've got to say plus c. That's not the big focus of today's lesson, but you do have, because it's indefinite integration, you have to have a family of functions, you have to have the plus c. But let's just not put it there because I want you to focus on the pattern right now. So what I want you to focus on the pattern, like if you've zoned out or anything like that, like now would be a good time to catch yourself. Don't worry too much about the derivative itself. Well, let me write out what I'm saying. I want to make sure. Okay, so let's look at, you are going to be given patterns, and in the very most basic, easy one today, you're going to be given f prime of g of x. So you're going to be given somebody's derivative with an inside function, and you're going to be hoping, at least, and today you will, that the derivative of the inside is floating around. So let's look at this and see if all of our pieces are there, because this is where it all happens. And so don't think too much about the prime to start with. This is my suggestion. Things will come to you. What I would like you to see is, can you find an outside function, right? And in the book, they're going to call that, can you find some f of x? Like if you have to read the book. Let's just do inside outside because that makes it so much easier. Can you find some outside function there? So let me stand up by the board and can you find some outside function? And really at this level, you're only going to have a couple of options. You're going to have something to a power, or you're going to have some kind of trig function. We don't bring logs in for another few weeks, right? So can you find like some kind of shell function that's got something holding in it? Can you? You see it? Doesn't really matter what it is. Can you see an outside? Can you see a shell function? Okay. And that's what you have to ask yourself when you're doing these problems. Go in and find a shell, right? So I see. Stand up there. I see an outside shell. I see something being squared. People, your book will call it x squared. It's the input. I see something being squared. Then go ahead and look at the inside of it. All right, go and look in the inside. And my inside, what's inside my shell? Well, that's your x squared plus 5. And your book will ask you to call that the g of x. That's this part that's in here. Right? They'll ask you for the f of x. They'll say f of x is input squared, x squared. The g of x is the x squared plus 5. And then, if this were perfect, and if this were a nice world, then the derivative of the inside would be there. And your book's going to call that g prime of x. Is the derivative of this also a factor? Yes, it is. So then, what makes this hard is there's no real rule. You just have pattern recognition. You have that pattern that this must be somebody's derivative using the chain rule. It has to be. Because it was like, originally our function was... Originally, right here, our function was a nice puzzle all in the box. Right? It was all in the box, got it for a gift. Then the whole family opened up the box and they laid everything out. So all the chains going on right there, and everything's got multiplied. Everything got laid out into the puzzle. Then we put that puzzle, that's puzzle laying in the table, and then the integral would be you packing it away. All right. So what we're going to do is once you've identified the pattern, some kind of shell, some kind of inside, and the derivative of that inside is multiplied along, then you just follow this so that you recognize that pattern. Then it must be the shell holder plus 1 divided by the new power using the power rule. The inside doesn't change. And basically you add your plus C. I've got to do it because it's accurate, right? But that's not the focal point of today's lesson. So let's just get right. That's not the recognizing the pattern. The plus C is just, it could be any one of those on any vertical line. But this, well, let's rewrite that. That's the same thing as 1/3 times x squared plus 5 to the power of 3. Now, can you see why the number one question that blows everyone's mind away is, where did the 2x go? Everyone has to struggle with that. Where did the 2x go? It didn't go anywhere. Remember, this is someone's derivative that used the chain rule to expand it. So you just put that puzzle back in the box. You didn't do it. It didn't go anywhere. It was just part of the pattern. That's why this is so much harder. You don't do a rule, derivative of the outside, leave the inside line, followed by the derivative of the inside. You have to pack that back up. You have to recognize the derivative of the inside and then stuff it back in the box. So, let's do one. So I'm going to ask you to, let's do some of the ones that I was going to assign as problems together. All right. So, and then I know a new way to pause this video now, so I can pause and walk around. So I am looking. All right. Oh, actually, I'll do it like this, and then you'll do the practice ones yourself. Okay, so I'll do, okay. So that's going to be, down the road, this will be like super, super easy. I want you to find for me, your book will say, what does your book say? I want you to find for me, f of x. That's going to be your outside function or the shell, right? That's not even a real word, so don't repeat that outside of this class because people will laugh at you. But and then I want you to find g of x. Your book will call that u sometimes, right? But let me tell you something about u. U substitution, we will use it, and a lot of people that help you in Math Lab might go straight to U substitution because they've done probably so much math that U substitution is always handy for them, or they want to, or that it's probably easier for you to do. U substitution on simple problems like this would be like using the quadratic formula to factor x squared minus 9. So you'd be doing a ton of work for something that doesn't require anything. Now, when we get to the end of the lecture purpose of this section, and you decide you want to do U substitution every time, I'm going to let you do it. You could do that. That's not a problem, right? But I'm definitely at least going to teach you the way I recommend doing it. And on problems like this, pattern recognition, while you can, because there's times you won't be able to, and times like this, I want you to recognize the pattern. So I'm going to want you to identify the outside the shell, the g of x. I won't use u right now, but your book will, which is going to be the inside. And I'm going to want you to find g prime of x, which is the derivative of the inside. Then I'm going to want you to pack it all back into the box and tell me what the answer is plus c. No, let's just do identify first, and then I'll pack it in with you. Let's do that. I want to identify first, because we're not gonna be on this for longer than like 35 seconds. So let me, and I under exaggerate. It'll be like 2 minutes. Alt Shift P. Okay, good. Now the people don't have to wait. Okay. What's the shell? What's the outside function? What's the inside function? What's the derivative of the inside?
Mr. Bird, do you have any headphones left in your house?
Headphones or plugs? Not that anyone gave to me.
I told you you were your plans. That's the definition of lost.
They're not cheap either, are they? You're so sorry. To do this fast, we get this time afterwards. Let's get this. Inside, outside, shell, inside, and derivative of the inside. Okay. So I'll give you like 20 more seconds and I'll call on someone. I know, right? I'll do random generator, see what you think. And then just be able to back your answer up. But if you're not right, there's nothing wrong with that. I'm just gonna keep going through till we get it. Put my random generator on 1, 2, 3. Go. Okay, so I'm going to do Alt-Shift-P. Okay, we're recording again. All right, so I have random generated. We're going to do group 1. That's right there up the front. And person 4. So that would be, I'd always start on the right. 1, 2. No, I should go that way. 1, 2, 3, 4. That's clockwise. All right. So give me, and I see you're right, give me the shell function. Yes. So input to the 4th, right? So you're going to call it. So you would say, like for a book answer, you would say the inside is going to be x to the 4th. I'll do it in different. So you'd say it's x to the 4th. Okay. Let's give someone else at that table a chance. 1. So I'm going to call you 1 from now on because that way it's 6. So then 1. All right. So what's the inside? X cubed plus 5. Well done. I'm not even going to write that because, well, I will. X cubed plus 5. And do I even need to hit this? 2. What is the derivative of the inside?
Is it all first table?
Yes, that first. Yeah.
Derivative of the inside is 3x squared.
3x squared plus 5. Okay. So you got no. All right, maybe then. Okay. All right. So here we go. So we have a shell function. We have an inside, and we have the derivative of the inside being multiplied. Does this fit the pattern? Yes, you've got the perfect pattern. This is the pattern where I'm talking about. We've got f prime of g of x multiplied by g prime of x. And remember, that's the derivative of f composite function. So if all right, now if this is the part you want to listen to. So it doesn't really matter. Don't worry too much about like what it is right now. So you've identified the shell was the 4th part. It might be a tangent. It might be a cosine. It might be a radical. It might be all, but you've identified the shell, right? So take the shell and do whatever rules necessary. So if it was trig, whose derivative is? If it's a power, add 1 to the power and divide by the new power. So I'm going to take my shell to the 4th, add 1 to the power, divide by the new power, plug the inside in, x cubed plus 5x, add the c, I'm done. Where did the 3x squared plus 5 go? Just packed up. It was in part of it. How do you know you're right? So like maybe for a Friday quiz, not talking about tomorrow, I'm not giving you a quiz tomorrow, right? But maybe for a Friday quiz, I would have you do one problem and then I would have you check it, because how do people in the real world do integrals? They have to check it. So how do I check that? If I multiplied something, I would divide to check it. If I added something, I would subtract to check it. Or actually, when I subtract, I add to check it. How would I find if this is correct? Take its derivative. So take the derivative of this and see if it's that. It is, right? Can you see it? So yeah, so you're with me. You're like, why is this so hard? Right? It's so you're gonna be getting, the trick is find the pattern. Because there are gonna be, of course, there are gonna be stumbling blocks that we're gonna put stuff in your way and we're gonna, but the first day, find the pattern. The shell, the inside, the derivative of the inside. And all we can really do to you is multiply by coefficients and mess things up and rewrite trig identities and things like that. So it's not that bad. You're almost there. So just find the shell, whatever that happens to be, the inside, the derivative of the inside. Okay, so the rest of the time is practice, but I want you really practicing. Of course you would if I didn't say that, but I'm just going to just emphasize it. So I want page, I don't know, Open up your books because I want to read the instructions to you because we're going to have to change them. Page 304, please. So if you have a book, you guys don't have a book over here because I think no one's in here first. You guys got books. Here's another one. There's one. Perfect. So if you guys can share one, maybe. And then you guys can share one. 304, please. 304 first, then ruin my book after that. Yes. What's the question? You asked me what's the inside function. The inside function is that.
So whenever it's like the outside, isn't it the outside?
No, the outside is, you said it right, is the power to, is a shell to the power of 4.
Oh,
No, right.
I thought the derivative for the g of x on the inside.
Yes, yes.
I thought you were have to like do it. This is already like
No, because this is the inside. You've said it right there. So your inside is your x cubed. So what is your x cubed plus 5x? You're missing your x there.
So this is the outside?
Oh, well, I didn't write it. It's probably x cubed plus 5x, yes. Yeah, that's okay, hang on a second. I'm going to sit and work with you individually, right? So let me finish the flow. No, we're not even done yet. Page 304, right? So look at the instructions. So, 1, you're going to be doing 1 and 4, 7 and 9. But I want you, for 1 and 4, you have to read the instructions with me, right? Because we are not going to identify u and du for today. So we're gonna talk about g of x and g prime x. It's the same exact thing, and when it rolls over, you'll be there. So we're gonna want to find the inside function and the derivative of the inside function. I also want you to find the outside function. It doesn't ask for it, but I want you to find just what we did. I want you to find the shell, the inside, the derivative of the inside. Then, so for 1 and 4, just identify, just find it. For 7 and for 9, I want you to full on find the integral. If you have got those and want something else, talk to me and I will find something. I might have you write one for someone, or I might find something that's a little bit trickier. So I don't want you full blank. Go ahead.
For 1 and 4, you said just get like the shell inside and the derivative on the inside.
Yep. So just find it and talk to me. Yep. Find the pattern. Find it. Yeah. This is yes, exactly. This is yep. That's the actual thing. Okay. All right. We good? All right. I'm gonna do this.
Mr. Burton, can I draw?
Yes. Sure. Let me stop this.